Okay, 7-2 is concerned with inverse functions, and inverse functions are very special in that, especially when you look at their graphs, they have corresponding points on your original function, and you can find a corresponding point on the inverse function where their x and y values are switched up. So if you take the original function and look at its x value on the inverse function, the y value was this x value, and then the x value on the inverse function is the y value on the original function. And we will do some of those graphs. It's very neat. I can just give you some random points, and then I can give you the actual corresponding function, and you can graph it, and you can see this is the actual graph. So it's kind of a cool way to get around it. And also the same thing as test questions. Remember, we're trying to very smartly go through these test questions, and they will give you a function and say which is the graph of the inverse. And if you know very quickly the y-intercept, or basically really the y-intercept, there is a problem on a practice test, take that y-intercept, you know that x and y value, go find the inverse of that point. Which graph has that inverse of that point? And it may narrow it down, and it may even give you the actual answer. But I digress. In your textbook, it tells you the way to find out if two functions are inverses is by checking these specific compositions, two of them. If you do f of g of x, you should get x, and if you get g of f of x, you should get x. And if both of these do come out to be x, then it's true that the two functions are inverses. If either of them come out to be any other value but x, then you do not have inverse functions. Now that's a lot of work. And we have done compositions, and you should be able to do them very well at this point. But there's another way to look at inverses. If you are given a function, remember that they have this special relationship of their ordered pairs where their x and y values are reversed. Let's take a function. F of x is 2x plus 5. And you know that f of x is kind of a placeholder for y. So if we just restate it, put that y back in, let's switch the x and y values in there to begin solving. So we put x in the y position and the y in the x position. And we always state a function as y equals 2, f of x equals 2. So let's just get y by itself. So you go about solving. So this is something you have done before. So move 5, solve for y, and just simplify everything. And so we have 1/2 x minus 5 over 2y. And if you want to, you can put this as 2.5. So the inverse of pointing 2x plus 5 is 1/2 x minus 2.5. And so that is the inverse. So if you were asked, maybe you get a question where it says, are these two inverses? Then you could go through the mathematical process of doing 2x plus 5 and see if it does come out with 1/2 x minus 2.5 y. So you could graph these two and look at, do you have some ordered pairs that are reversed? And that would help you to find if they are in fact inverses. This is a way that you find inverse functions of one another. And this is another example. So remember that we can check inverses that way. And of course we do have compositions, but keep that in your toolbox, and we will answer some further questions about inverse functions and actually take a look at their graphs.